Hello viewers, today we will discuss all the steps or hidden construction processes to start a pipeline project till handing over to the client. So this video might take some longer, but the informations are very important, especially who are very new to the pipeline. Let's start. Construction project actually starts much before the site construction activity started. So there are some activities which are not visible at site, but people are working from the client, make a preliminary survey to decide the pipeline route. So that's why design key plan is getting prepared. If it is a LSTK project, about LSTK, LSPB I have discussed in my previous video. If you have not seen yet, please go through it. LSTK means lump sum turnkey. That means the contractor who is awarded this project to do start the design, then procurement, then construction and handover, complete handover. After the project is awarded to the contractor, the company will hand over the key design to the contractor officially. Contractor will appoint a company approved design contractor who will detail the design and provide the contractor all types of drawing required to construct the pipeline and its related facilities, piping, etc. When the designs are under review, there are 30, 60, 80 or 100% review before IFC. This review will be done by the contractor engineering group as well as the company engineering team. Company will build up a team which is called project management team. They will be at the site to manage the contractor and hand over to the owner of the project who is proponent. These detailed drawings will be reviewed by contractor engineering department, the project management team which is termed as PMT, and also by the proponent, so that if they have any objection they will raise it from now and the design and detailed designing can be revised accordingly. So after this design is issuing the IFC, the material requisition will be started by the contractor procurement department. This material requisition includes only the material contractor need to procure. Generally in the pipeline project, line pipes and some fittings, some spools are being supplied by the company, and the remaining materials, it is already predefined, will be procured by the contractor procurement team. So the procurement team as well as the design and detail designing guys are working inside the office to make the project ready for construction. In parallel, Contractor Logistics department got very busy with the following: finalize site project office and accommodation camp. In most of the cases, LUP means land use permit acquired from the client allotted land. Mobilize site team to construction office and accommodation as per approved contractor facility design and drawings. Contractor must follow company general instruction and HSC requirement while constructing their facility. They will arrange and build construction facilities like workshop, fabrication shop, secure the laydown yard to make it ready to preserve project material, and build warehouses to store the project materials. Logistics department will time to time invite the contractor QC department for arranging inspection and approval from company inspection department prior to start using the newly built facilities. Logistics department to arrange and mobilize equipment, tools, transport for the construction team. Sometime, if project is nearby any city or village, contractor may rent their facility to avoid huge mobilization cost, and also it saved a lot of time. They can rent the facilities and immediately can start their work. Besides this, site management team is active with the following: HR means Human Resource Department, who works tirelessly since very beginning of the project to search the manpower, resources, arranging salary for the employees. So they have to set up their system following contractor HR policy. The design and procurement department, they are the first department to start the work in contractor main city office. Sometimes these offices provided by design contractor. Construction management and engineer will be busy preparing construction records, construction related procedure, method statement which is required to start the project. Planning and project scheduling department to prepare the project schedule and planning documents. They have to set up the reporting procedure, how the progress will be reported weekly, daily or monthly. Quality assurance and control manager to prepare and submit gradually all project quality deliverables. For example, project quality plan, all quality procedures, all special procedure, service provider procedures, NDT, calibration, civil testing lab, for example. Generally, the welding engineer prepare the welding procedure qualification, which is called PWPS, that means pre-welding procedure, which is a basis to start the welding procedure qualification test as soon as fabrication shop is ready. Approval of WPS will take some time. Submission of all documents to follow the time limit from company guideline and code or standard. Similarly, safety department to prepare and submit safety manual and procedures. They have to submit the HIP, hazard identification plan. Also, they need to get the camp approved from company loss prevention department, company safety department. They have to see the welfare and safety of the people who will be living from contractor side in their facilities. Warehouse and store management is busy in establishing their inventory control system, planning and marking the layout to make the facilities ready to accept project material, daily consumables, etc. Finally, contractor start mobilizing manpower, equipment operators, catering services, medical clinic, doctors, male nurse, laundry, etc. All construction, quality, safety and other departments gradually starting employ and mobilize engineers, inspectors, safety officers as required in the project manpower deployment schedule. Generally, pipeline construction work starts with site survey to mark the pipeline route. The major site activities in sequence can be described as right-of-way preparation. That means the temporary marl road beside the pipeline from where the manpower equipment should access to construct the pipeline. The access road is prepared. Now the equipment comes to start trench excavation in case of underground pipeline, and in case of above ground pipeline they need to prepare it, put the pipeline typical supports where the above ground pipeline will run on. Oil pad or manifold or GGM or gauze pad preparation where the civil foundation can be started slowly. The materials for pipeline API 5L carbon steel like X60, X65, X70 are being used. Line pipes laying or stringing along the right of way. This is the next activity. So line pipe receiving inspection generally done when the pipe is directly laid from the trailer to the right of way. FBE coated line pipes in case of underground pipe and bare line pipe for above ground pipeline are supplied by the company. FBE coating protection is the major responsibility of the contractor. In parallel, in the fabrication shop, welding procedure qualification test ongoing. After the procedure qualification test report come, contractor quality department need to submit the welding procedure for company approval. When the welding procedure is approved, then welders should be qualified accordingly. Number of welding procedure required will be decided by the welding engineer and the QA/QC manager by analyzing the types of material, their grade, their thickness, When welders are ready, their job clearance card need to be prepared and need to get approval from the project inspection department. Accordingly, NDT procedures are approved. So now the site is ready to start the welding. Welding cannot be started if the non-destructive testing contractor is not mobilized. If the pipeline goes through automatic welding, then the NDT procedure is automatic UT. And if it is manual welding, then the NDT required generally radiographic test. When the NDT crew is mobilized, then the pipeline welding can be started. The first 40 welds or the first day production, whichever is more, will be facing 100% of NDT, means radiography. In case of automatic welding, the percentage of automatic UT is always 100%. If this first lot of radiography comes satisfactory, then random radiography shall be chosen. Another important thing, pipeline requires internal welding clamp for the root fit up for 16-inch and more diameter. If contractor doesn't have this internal clamp, they can proceed with the external clamp for the root fit up, but they have to adopt 100% NDT or radiography for all the girth welds. Pipeline welding processes. Generally, SMAW is being used for the mainline welding, means argon root, and SMAW means stick welding for the filling capping is being done for the tie-in welding, especially if the line is internally coated to protect the root from spatters, to get the concave shape of the root so that internal coating for the girth weld get adequate thickness at the root also. MIG or MAG welding, manual inert gas welding or manual active gas welding, generally used for automatic welding. It is also pipeline, very popular procedure where the root is STT, which is semi-automatic MIG welding, and then the filling capping, FCAW, flux cored arc wires with 80-20 carbon and argon gas mixture. Generally, this is a fully automatic process, filling capping, and the root is STT, which is semi-automatic. Wire feed is automatic, but the welding holder manipulation is by the welder. For underground pipeline, when sufficient welded strings are ready, it will be lowered with the help of sufficient side booms, minimum 2 or 3, inside the pre-excavated trench. Trenches to be inspected and accepted by both contractor and company inspection. Strings are being tied to each others by means of welding. These welding are termed as tie-in welding, which are being welded inside the trench. These are a bit difficult due to the limited space around the joint, especially for the big bore pipes. So the welded strings now connected together inside the trench in case of underground pipeline. At the both end of the pipe, to prevent the pipe deflection transferred to the piping at the end, there are huge concrete solid blocks casted around the pipeline at both ends, underground in case of buried pipeline, just before pipeline enters facilities to connect with the piping system. These are termed as full thrust anchor. This is the time to install the full thrust anchor. As the name suggests, size and volume of the concrete designed to resist the thrust that is exerted by the long pipeline heat expansion or shrinkage or uneven flow of the service gas or oil. Full thrust anchor is protecting the facility piping system which are connected to the pipeline by arresting pipeline expansion or shrinkage. Otherwise, it could have break the piping system. There are also removable structural steel anchor found for comparatively small lines and above ground pipelines. For above ground pipelines with oil and crude oil service installed over steel supports which are based on TPS, means typical pipe concrete bases, thermal expansion or shrinkage are being compensated by expansion loop 90-degree L or C loops. Since long radius elbows installed in these types of lines not scrapable, means for maintenance scraper cannot be passed through these lines. For underground lines, there are 5D or 8D long radius bends installed to avoid sharp turns to facilitate easy scraper run. Pipe bending. Pipe bends are required when there is a noticeable direction change of the pipeline, which are termed as horizontal curves. Also, when there is remarkable elevation difference, climbing or going down from hilly terrain, we need over and sag bends. For underground pipeline, at both ends where the pipeline transiting from underground to above ground risers, we need also pipe bends. There are basically two types of bends used in the pipeline: hot bend and cold bend. Contractors are only allowed to make cold preform bend at site with the help of bending machine. Hot bends are only permitted to be manufactured at company approved vendor facility. Hot bends are preferred where steeper long radius bends are required due to space constraint. Risers of flow line. This is an example. Another activity in the pipeline is temperature tie-in weld. Generally, one string of the pipeline is 1 kilometer to 1.2 kilometer. So these strings are connected together with tie-in weld. When the full pipeline is lowered, welded completely and backfilled for underground pipeline and installed over steel support in case of above ground pipelines, there will be one or more final welds where the both ends are adequately anchored by the longer backfill section, or full thrust anchor at other end where the slack of the pipeline open strings cannot be transferred or moved to the other end. These tie-in welds are termed as temperature tie-in welds. Backfilling and berming. In parallel to welding string lowering and tie-in welding, lowered portion are getting backfilled with 300 mm sweet sand without any rock or stones, followed by the marl cap layers. The total marl cover shall be minimum 900 mm from the top of the pipe. A trapezium shaped berm to be prepared with gentle compaction manually. Previously, crude oils are being sprinkled over the finished berm as a stabilizer, which is protecting the berm marls to be blown away by the wind. But nowadays, due to safety hazard for the camels, only water stabilization is permitted. Now the line is welded, backfilled, and flange to flange is continuous. Now the next activity is the hydrotest, which is the final acceptance of the integrity of the pipeline. We need to make sure that all the required welding has been done, all NDT successfully done and accepted by company representative, hydrotest package to be prepared and approval to be taken from company. Prior to commence hydrotest related activities, there are few sub activities involved in the hydrotesting. So immediately after the line is completed from flange to flange, we have to prepare for pipeline internal cleaning to make sure that there is no foreign material inside, no sand, no mill scale. If it is internally coated line, hard scraper cannot be put inside the line. It will be only foam scraper and generally run with water to clean. Internal gauging also done for the bare pipeline, I mean internally not coated, to check the pipe diameter is not deviating than the tolerance anywhere. One aluminum gauging plate is put with the scraper, which is 90 to 95% of the internal diameter of the pipeline. If there is any damage of this gauging plate when it came out from the line, then the damage is being measured. If it is beyond limit or the tolerance, then the investigation must be done to find out any dent or any external damage from the pipeline. For the bigger trunk line or production lines, there are more accurate method is being implemented to measure the internal diameter of the pipeline to verify any dents or damage is called Calliper gauging. It is an intelligent digital tool which is installed with an intelligent scraper giving a graphical representation of the internal wall of the whole pipeline. This is accurately verifies the internal diameter of the pipeline. Calliper survey. One report I am attaching for you as a sample and your better understanding. Next activity is bolt torquing after installing test header or test manifolds. So manifolds are kind of safety attachments. If there is any pressure leakage, there will be pressure relief valve in the hydrotest manifold. Next activity is water filling. The water to be induced in the pipeline has to be tested for its quality to check it will not corrode the pipeline from inside, the chemical content in the water not react with the pipeline adversely. Sometimes if it is a big line, filling, hydrotesting and dewatering will take longer time, more than 14-15 days or more than 30 days. Then some chemical called oxygen scavenger need to be added to protect the line. The oxygen scavenger calculations are being provided by contractor. When the water is filled, we have to wait for the stabilization of the water and pressurization to be started gradually. There should be some steps to be followed for raising the pressure, 50% pressure, then gradually 10% will increase till we reach to the strength test. Pipeline, there is a thumb rule to test the line at a pressure of 90% of specified minimum yield strength, SMAW. And this is much higher than the MAOP, maximum operating pressure of the line. So when we reach to the strength test pressure, which we will be keeping for 2 hours, the line is being checked for any leakage or something during this holding time. If it performs well, the strength test pressure is reduced to 5% to reach the tightness test pressure. This tightness test pressure will be further running 24 hours. Since the line is underground, we cannot inspect the line for leakage. That's why this 24-hour tightness test is required. All these test pressures, since pressurization starts to the end, is being recorded by a pressure recorder chart, at least 2 to 3 pressure gauges, and there will be relief valves at the both sides. And sometimes as an additional safety measures, in case the pressure recorder malfunctions, dead weight tester means manually the pressure also being monitored time to time. After the successful acceptance of the hydrotest, project inspection from company and the contractor quality inspector reviews the pressure chart and signs there. Then the depressurization started, followed by dewatering and then swabbing and drying. Line has been dried for several days in case of big lines. With the dry air, -1 degree centigrade of dew point achieved, the contractor need to push nitrogen from one end, and generally this nitrogen gives a very good result for dew point. It can reach up to -30 to -40 degree centigrade, and a positive 30 to 50 degree psi pressure of nitrogen is being maintained in this closed system to protect it from corrosion till the pipeline goes into service. Now the pipeline being accepted, there are few more activities in the pipeline. Chemical cleaning. This process is required for the refined product pipelines so that the line will leave no rust or mill scale inside the pipeline prior to introduce finished service products like kerosene, diesel for transportation. Piping and valve and instrument installation, this is also being done in parallel with the pipeline construction or after the pipeline has been completed. Both ends of the pipeline, there can be a remote manifold, scraper trap and utility facility which can be inside or outside of a secured facility plant area. Shop fabrication, installation of piping, valves, instruments like pressure gauge, pressure and temperature transmitter, scraper passage indicators, LDS means leak detection system to be completed in parallel with pipeline construction work. We can discuss about the piping works in another video later on. Cathodic protection, an additional protection for the underground pipeline to increase their service life to a greater extent. For example, if there is no cathodic protection, the service life of a pipeline may be 10 years. But if you put cathodic protection, the life can be extended up to 25 years. This is a figure I am giving you only to understand the utility of cathodic protection. Cathodic protection, a small amount of impressed current flowing through the pipeline which is giving cathodic effect. It is degrading the anode installed in the line, leaving the pipeline free of corrosion or rust. CP cables to be connected through thermite welding on the pipeline in every crossings and the areas recommended in the drawings. Temporary CP that is magnesium anodes, to be installed place to place, which will protect the line till permanent CP is installed and during the construction phase. Mechanical, electrical, instrumentation and telecommunication completion. Based on the project scope, electrical and telecommunication cable laying, backfilling, termination, equipment like scraper trap, jeep cranes, scraper handling facility, pressure gauge, pressure transmitter, temperature transmitter, thermowells, RTU, junction boxes, switch racks, SCADA, CP rectifiers, leak detection systems to be installed over the pipeline based on the scope of the project. All these instruments, equipment need to be tested to prove their functionality. E&I means electrical and instrumentation telecom system to be connected with the company terminals. Motor operated valve, hydraulic operated valve, MOV, HOV, pressure control valve, PCV to be connected to the RTU or hydraulic system as required. Painting coating items completion. This is another department. During all the construction stages, coating and wrapping of the pipeline girth welds, metallic coating of the above ground pipeline, stenciling of the line, equipment identification numbers are ongoing. There are usually many no PMCC items related to paint touch-up, stenciling which are being closed at the final stages of the project. Pipeline completion. After successful completion of the pipeline, a final walkthrough with company and contractor representative team to find the remaining work for safety and quality being organized. Outcome is bunch of remaining items which are termed as PMCC, Project Mechanical Completion Certificate items. PMCC items. There are yes and no item. Yes items are the items required to commission the line. When done, MCC is being issued to the company. So PMCC is the remaining work, which can be small or big, but remaining work. For complete handover of the project, either LSTK or LSPB, contractor must close all PMCC items, which can be yes or no. If some items in the PMCC can be proven as beyond the work scope of the contractor, it is the sole responsibility of the company to decide to award it to the same contractor as a change of scope order or give this additional scope to others. Upon completion of PMCC, contractor needs to remove their facility, camp or office, demolish and reinstate the company provided area to claim the retention money held by the company. Company may issue appreciation and successful completion certificate to the contractor based on their satisfaction. So viewers, today I think I have explained brief process overview of pipeline construction. If you still have any questions, we can discuss further. If you need a specific video on some of this, please request me in the comment section. I can explain it for you. If you like, please share and subscribe my channel to your friends. Thank you. Signing off, Showman.